Okay, so what we're going to do is we're going to look at, we have a whole bunch of lines here. So our project was we had to make a bunch of linear equations, and this was our spaceship, had a circle involved in it there. And what we needed to do is we needed to make sure that our lines touched the spaceship, but also went through each of the aliens, which we have at this point. All of the aliens have been contacted or hit, or however you want to describe it. What we're going to do next is we're going to find a system of equations. So a system of equations is where equations will interact or intersect each other. So it might be hard to see because there's a lot going on down there, but these are where all of our equations are intersecting each other. So let me zoom in a bit. And I can even click this one. Okay, so this technically here is a point of intersection. It's a bit hard to see. See it again, there you go. It's at negative 28.182 and 0.455. So because these aren't very nice numbers, we can still apply our formulas, but it can be difficult to work with. What we're going to do is we're going to figure out how to find those algebraically. So graphically, we can see them. We can see the two lines intersect with each other, but we need to get the equations of the two lines. So as I click this line, you'll see this one here, it lights up. So that's the purple line. And the blue line is this line here. Okay, so what I'm going to do is be able to copy it, and I think, can I just paste it in here? Let's see if I can insert it. All right, it's written it that way. We'll rewrite it. Let's get the other one. There's the blue one, and then we want the purple one. I think that was this one here. Okay, I'll rewrite those. Okay, so what we have is we have our two equations. They're not so nice the way they're written, so we're gonna redo that a bit. There we go, sorry. Okay, let's rewrite these two equations. The first equation is y is equal to, this stands for fraction, it just means negative 3 over 10x minus 8, okay? And this one here is y, and this one means fraction, is equal to 1 over 4x plus 7.5. So we have fractions, we have decimals, there's a lot going on in this page. What we're going to do is we're going to use a method called substitution. So I'm actually going to try it with an easier value first, and then we're going to come back to this page here, okay? So what we're going to do is I'm going to jump to the next page. We'll make up a little equation here. We'll say y is equal to 2x plus 1. That's one equation. And the other equation will be y is equal to 4x minus 3, we'll say. Okay, so these are two linear equations. This is the slope of equation 1. This is the slope of equation 2. This is the y-intercept of equation 1. And this is the y-intercept of equation 2. So if we had to do a rough sketch, okay, I'm going to do a rough sketch here. We could say there is a y-intercept on the equation 1. It's at about 1 here. And if you recall from what we talked about before, oops, let's do that. 2, we can turn it into a fraction, 2 over 1. So I'd say it goes up 1, 2 over 1. And then same idea, you can do the opposite. You can go down 2 and to the left 1. And we kind of create a line roughly through there, okay? And then for equation 2, same idea. If we were to do a rough sketch, we have a y-intercept of negative 3, so that's probably somewhere down here. And the slope is much steeper, the slope. It goes up 4, so let's say like 1, 2, 3, 4, and over 1, up 1, 2, 3, 4, over 1. Maybe something around there. This is a rough sketch, so we don't know exactly where it is, but it's somewhere in this positive range. Here's our x value and a y value. So graphically on a sketch, because a sketch isn't drawn to scale, we get a general idea where they intersect, but we'd have to be really specific, and it may not even be whole value numbers. So what we're going to do next is we're going to algebraically solve through substitution. Okay, so this is a tricky thing, and this is a big part of your math this year, we'll call it. So I'm going to get you to walk us through the second part. So you're going to watch this part, and then you're going to go through the second part together. In substitution, we have two variables, and we have two equations. We have an x and a y in each equation. What we want to do is we want to set one equation equal to a variable and sub the other equation in for it. Luckily, because we are using the slope y-intercept form, both these equations are already set equal to a variable. In fact, y is equal to all of this stuff over here. That's what that means. So if I rewrite equation 2, I'll put it out there again, y is equal to 4x minus 3. Well, I can actually replace the letter y with everything on this side of the equation because we know y is equal to it. So in the next line, I'm actually going to write 2x plus 1. And that actually comes from equation 1. It's just the right-hand side of the equal side. Okay? So we've replaced or substituted that in for y. The next thing we want to do is we want to isolate our variables. We want to get anything that has a variable on the same side of the equation, and anything that's a constant value, we want that on the same side of the equation. So we'll start by moving, I'll move 2x over to this side. Now because 2x is positive here, to create a 0, we technically have to subtract each side by negative 2x, but a lot of times they'll describe it as just bringing 2x to the other side and changing the sign. So we can do that. Let's say subtract 2x, and we still have that minus 3. Now, I have the variables on the same side. I'm going to take this constant. I'm going to move that to the other side. Same idea. To create a 0, we have to add 3. So when we move that over, it becomes 1 plus 3 is equal to 4x minus 2. Okay, so this is good. We're starting to get down. We've got one variable. We're going to collect our like terms, and there should be an x here. 4x minus 2x gives us 2x, and 1 plus 3 is 4. Okay. The final step is we really need to make sure we get x by itself. So in order to get it by itself, because this is multiplication, we need to divide both sides by 2, and we get x is equal to 2. Amazing. And that doesn't look bad. That means somewhere here, when x is 2, that's where they intersect. We just don't know what the y value is at this point. So because we have this piece, we need to substitute that back into one of the two equations. It doesn't actually matter which one. In fact, we could do it to both. Let's just choose the very first one, 2x plus 1. So equation 1 said y equals 2x plus 1. Okay. We now have a value for x. So we can replace x in this equation with the value of 2. So we're going to do that. Let's work through this side. Y, whoops, let's put that in black. Y is equal to 2 multiplied by 2 plus 1. That means y is equal to 4 plus 1. Y is equal to 5. Sorry, I wrote 5 in anticipation up here, but it should have been plus 1. So what that means is the point where they intersect, the x value is 2, and the y value is 5. And if we go look at our rough sketch, yeah, that looks about right. It's probably somewhere around there, right? Our sketch gives us a value similar to that idea. So that's how we go through the method of substitution, okay?
Yeah.
Now what I want you to try, let me go back, is this question. It's got fractions and decimal. It's a little trickier, this question here. So before we do that, let's jump out.